Hi, this is Michelle Hobbs. I will be recording exam 3, part 2 of the practice quizzes. Okay. All right, let's see here. So we are going into the very first question. All right, so let's see. Excuse me. Classify each pair of samples as independent or dependent. Sample 1, weights of 65 college students before their freshman year begins. Sample 2, weights of the same 65 college students after their freshman year. Let me get a quick little review here, because I need a little review.
We have a question here. The question says, two sample z-tests for the difference between means. The question says, a credit card watchdog group claims that there is a difference in the mean credit card debts of households in California and Illinois. The results of a random survey of 250 households from each state are shown at the left-hand side. So for California, it seems like the mean is 4,777, and N1, the sample size is 250. For the second state, Illinois, the mean is 4,866 with sample size 250. So now the question is, by assumption that the samples are independent from each other and the population standard deviations from past studies are given, do you support the claim or not? So this is the question that we want to answer. Note that we have two populations right now. We took two samples from two populations, and we are interested in forming a hypothesis test and analyze these data. But we need some basic information first. First, we need to know what is the definition of dependent and independent samples. Two samples are called independent when the sample selected from one population is not related to the sample selected from the second population.
Okay, so two samples are independent when the sample selected from one population is not related to the sample selected from the second population. Two samples are dependent when each member of one sample corresponds to a member of the other sample. Okay. So weights of 65 college students before their freshman year begins, weights of the same 65 college students. That is our hint there. They're dependent when each member corresponds to a member of the other sample. So they are going to be dependent because they are the same samples. Dependent, yes. Next. So here we go again. Classify each pair of samples as independent or dependent. So sample 1 scores for 38 adult males on a psychological screening test, and then scores for 50 adult females. So this is going to be independent because they are two different sample populations. One is males, one is females. Okay, I think this is the old one. All right, so, oh, next question. A credit card watchdog group claims that there's a difference in the mean credit card debts of households in California and Illinois. The results of a random survey of 250 households from each state are shown at the left. The two samples are independent. Okay. Do the results support the group's claims? Well, let's pull this up real quick just to get a little peekaroo.
Now that we talked about two population mean and the hypothesis testing using z-scores, you're interested in knowing what if z is not given. If we cannot use z,
Oh,
z-scores, you're interested in knowing what if z is not given. If we cannot use z,
okay. I'm gonna look at this picture here and try to plug everything in. So is this a two tail or a right tail or a left tail? Let's see. The test is a two-tailed test. So it is a, oops, two tail. And then the is standardized test statistics is going to be negative 0.82. And do we reject the claim? There's not enough evidence at the 5% level of significance to support the group's claim. The figure at the left shows the location of rejection regions. You fail to reject the null hypothesis. You reject the claim. So failing to reject it means you're not rejecting it. So do you reject the claim? No.
so far we ran a hypothesis test for a left tail test. In this question, we have a right tail test. Let's read the question carefully. To compare the amount spent in the first 3 months by clients of two meal replacement diets, a researcher randomly selected 20 clients for each diet. The mean amount spent for diet A is $643. Assume the population standard deviation is given to us as 89. The mean amount spent for second diet B, is $588. And assume the population standard deviation is $75. At 1% level of significance, can the researcher support the claim that the mean amount spent in the first 3 months by clients of diet A is greater than the mean amount spent in the first 3 months by client B? Very good. So it's definitely a Z test. Why? Because we are comparing the population means and you have two different diets, two different sets of clients, and sigma 1, sigma 2, or population standard deviations are given to us. So let us follow these steps. Verify sigma 1 and sigma 2 are given. Let us go back to the question. The question says for diet A, the average is 643 with standard deviation of 89 for population. So we have sigma 1, 89. For the second population, well, we took a sample and the sample mean is 588 with a population standard deviation of $75. So sigma 1 and sigma 2 are given. We have a random selection and they are definitely independent from each other. You have a set of clients for diet A, another set of clients for diet B, so they are independent from each other. And let's see what else is given to us. We also know that the populations are normally distributed. Let's see. Do we have any information about that written here? Well, we assume the population are normally distributed. Otherwise, we cannot apply these steps. Step that claim mathematically. Very good. So look for the claim. Claim, where is the claim? You have a researcher randomly selected clients, and then that researcher says that the mean amount spent in the first 3 months by client A is greater than. So this is the keyword for you, greater than. Very good. What's the meaning of that? It means that the alternative hypothesis is given to you, everybody. So the claim says mu1 is more than mu2. Its opposite, its complement is mu1 less than equals to mu2. What's the next step? Identify the level of significance, which is given to us as 1%. Determine the critical values and the rejection region. Perfect. Since you have a right tail test, mu1 is more than mu2, so you have a right tail test. And your alpha is 1%, z sub 0 is 2.33 using inverse norm. So as long as your z standardized test statistic is inside the rejection region, it means that it's more than 2.33, you reject the null hypothesis. But we need to do the calculation. Z is equal to x1 bar minus x2 bar minus mu1 minus mu2 divided by square root of sigma 1 squared over n1 plus sigma 2 squared over n2. x1 bar, where is that? The first diet average, which is 643, minus x2 bar, which is 588. We're going to copy that here. Minus the difference between population means always assume it is 0. Divided by the first standard deviation is 89. Divided by, well, we have 20 clients plus the second standard deviation is 75, raise it to the second power, divide by n2, which is 20. When we do the calculation, this is the standardized test statistic that we have, 2.11. Well, is 2.11 on the right-hand side of 2.33? Remember that you have a right tail test. So as long as this number is on the right-hand side of 2.33, you're going to reject the null hypothesis. Otherwise, I say that, well, not that case. Since z is less than 2.33, it means that it's not in the rejection region. So you say that we fail to reject the null hypothesis. When you fail to reject the null hypothesis, it means that you support the null hypothesis. So when you support the null hypothesis, you're going to reject the claim. Why? Because the claim and the alternative hypothesis are the same thing. There is not enough evidence at 1% level of significance.
Got it. So I'm just like kind of following along and learning with the question. Math test example.
We're going to see an example about hypothesis testing for two populations and checking the claim. In this example, we have the following scenario. I would like to check to see what's the difference between average test scores in San Jose State University and, for example, Stanford University. What I'm going to do, I'm going to claim that I think there is a difference between average math test scores in San Jose State University and Stanford. And in these was 459. I had 80 students in the first exam in San Jose State University, and I have 18 students in the second sample from Stanford. I calculated the standard deviation. I don't have information about the standard deviation of populations here. This is just a new test. This is what I designed. S1 is equal to 39.7, and S2 is equal to 24.5. So should I reject or support my claim? First of all, let us form the null and alternative hypothesis. Null and alternative hypothesis. Well, this is what I'm thinking. This is my claim. There is a difference. It means that they are not equal to each other. So the claim is mu1 is not the same as mu2. It's opposite, it's complement. You don't have your T. You have the difference between sample means minus the difference between population means divided by, now we have the square root of, instead of sigma, we're going to use S, sample standard deviation. S1 squared over N1 plus S2 squared over N2. We're going to punch off the 59 minus the 8 agreed to take the test, plus standard deviation from the second university, 24.5 for the second, divided by the number of people, the number of students. Well, your calculation shows 0.9. Very good. So this is your T, right? Well, now that you have your T, you need to be able to find the p-value. But how? You can use a calculator. Take a look. Let's turn on the calculator. I know my batteries are low. Actual data, I find 0.24 because the difference just died. Very good. So it seems like a p-value is about 30%, 0.3 or 30%. So let us compare p-value and alpha. Alpha is not given to us, so let us select alpha to be 5%.
Okay, moving on to question number 6.
So when you have two sample tests for independent samples, these are the steps that we need to follow. If population standard deviations are given to us, we're going to use z-test, these steps here. The results for samples of two types of pets are shown at the left-hand side. For dogs, the average is 239, its standard deviation 32, and sample size is 16. For cats, it's 2 or 3, its standard deviation 21, and sample size 18. At 10% level of significance, can you reject the pet association claims? Assume population variances are not equal to each other. They are not equal to each other, so the degrees of freedom must be the smaller of n1 minus 1 and n2 minus 1. So first of all, since the claim says they are equal to each other, it means that your null hypothesis is the claim. mu1 is equal to mu2. You can easily create the alternative, which is mu1 is not the same as mu2. Since the population variances are not equal to each other, it means that the degrees of freedom is the smaller of n1 minus 1, n2 minus 1. n1 is 16, 16 minus 1 is 15, n2 is 18, 18 minus 1 is 17. So between 15 and 17, 15 is smaller. Now, since you have two-tailed test and your alpha is 10%, 10% divided by 2, 5%. The critical value for 5% area is 1.753 and negative 1.753. So the rejection regions are on the left and right side of these two numbers. Now we need to move on and calculate the the standardized test statistic, which is T equals to x1 bar minus x2 bar minus mu1 minus mu2 divided by the standard error. x1 bar is 239 minus x2 bar 203 minus the difference between population means is 0 divided by square root of s1 is 32 raised to second over 16 plus s2 which is 21 to the second divided by 18. This number is about 3.83 and this is more than 1.753. It means that this lands in the rejection region. So you're going to reject the null hypothesis. You're going to reject the null hypothesis. We're going to reject the claim. When you reject the claim, it means that you support the alternative hypothesis. So you're going to say that there is enough evidence at 10% level of significance to reject the claim that the mean annual costs are the same. So again, this formula is for the case that population variances are not equal to each other. If the question says population variances are equal, the formula that you're going to follow is a little bit different. Here you have a pooled sample. So transactions. A magazine claims that the mean amount spent by a customer at Burger Stop is greater than the mean amount spent by a customer at Fry World. The results for samples of customers transactions for two fast food restaurants are shown at the left-hand side. So X1 bar, the first average is $5.46, with standard deviation 0.89, and the sample size 22. The second average is 5.12, with standard deviation 0.79, and sample size 30. Well, first of all, what is the claim? The claim is that the mean amount spent by customer at Fry Board and Burger Stop are different from each other. It says the first one, the average is more.
Okay, and then I answered that question by looking at the numbers here. 10% is higher than 1%. And then for this one, 0.5 is lower than 1%. So I was able to answer those questions. And that completes part 2 of the practice exam.